Literal equations, CP Algebra 1, Miss Miller. Our objective in this flipped lesson is that you will be able to solve literal equations for a given variable using your prior knowledge of solving linear equations, and you'll be able to apply it to understanding of cross-curricular applications, meaning that you'll be able to apply what we learned here today to classes such as geometry, physics, chemistry. A lot of different classes end up using literal equations to solve. What is a literal equation? A literal equation is an equation that involves two or more variables, also known as a formula. Literal equations are used to represent formulas such as average speed, distance, time, interest, and slope, all of which we'll be analyzing throughout the course this year. In order to keep going, I want you to use your guided notes. Notice that I separated your guided notes into what you already know and what will be new. This will be activating our prior knowledge of you solving linear equations. What we know how to do is to solve one variable. If we take a look, we're asked to solve for x, given that x is our only variable in this equation. I want you to take a look at this equation and think to yourself, what would you do first? I hope that you decided to subtract 6 from both sides of the equation. Subtracting 6 is using your subtraction property of equality. When you simplify, you end up with 2x still being on the left-hand side of your equation, but now instead of equaling 8, it's now going to equal 2. Now I want you to think to yourself, then what would you do? Since 2 is being multiplied to x, we want to do the opposite operation, which would be to divide by 2 to both sides. This will cancel out the 2 times x, leaving us with just x. This is our division property of equality. Once x is alone, we get x equals 1. Did we solve for x? This is something we should always think about when solving an equation. And yes, we did. Now let's look at what's new. This is an equation with only variables, which is called a literal equation. Notice that A represents the 2 here, B represents 6, and C represents 8. Well, using what we know, we can apply it to what is new. Since we subtracted 6 from both sides to get 2x by itself, let's try subtracting b to both sides. This is using, again, our subtraction property of equality. However, 8 and 6 were like terms, which allowed us to simplify it to be 2. This time we have to subtract c minus b, and since they cannot combine, we leave it as ax equals c minus b. Now I want you to ask yourself, then what should you do? Since it's a times x, we should divide by a. Whatever I do to one side, I have to do to the other, and to everything on the other side of the equation. This is using our division property of equality. By dividing by a, it cancels out, and x equals c minus b over a. Did we solve for x? Of course we did. As we said before, literal equations are used in everyday formulas, such as the area of a triangle. If I give you that the area is 24 inches squared, and the triangle has a base of 6 inches, I want you to write the equation for the missing variable, which would be height. Well, the only thing I know is that area equals 1/2 base times height. Let's try plugging in what we know. 24 is my area, and 6 is my base. But this isn't the equation for height. We're going to have to solve for it. Let's use what we know to try and solve. Let's first get rid of this 1/2. Knowing my multiplication property of identities, I know I can multiply by the reciprocal of 1/2, which is 2. By multiplying by 2, it'll cancel out, and I have to do whatever I do to one side, I do to the other. So I end up with 48 equaling 6h. Since I'm solving for h, I'm going to look at 6 times h. The opposite operation would be to divide both sides, which gives me 8 equaling h, which we know to be 8 inches from the previous problem. And we did solve for h. I want you to pause your video here and see if you can solve for h in a literal equation. I hope you paused your video and you tried on your own. If you're stuck or you have no clue what you're doing, follow along with me again. We're going to multiply by the reciprocal of 2 to both sides. This will cancel out. Once we do that, I'm left with 2a equals bh. b times h, the opposite operation would be to divide, but divide by what? Since I'm asked to solve for h, I'm going to divide by b. So my final equation is h is equal to 2a over b. Let's check to see if this is equivalent. Going back to our original problem, I'm going to find the height given my information, but now using my height formula, h equaling 2a over b. Let's plug in what we know. So I have 2 times 24 divided by 6, which gives me 8 inches, which is what we solved for before. Another popular formula is when we convert Celsius to Fahrenheit. Here is an example where I've told you the Celsius and we need to solve for F, our Fahrenheit. Similar to before, I'm going to multiply by the reciprocal, which would be 9 over 5. This will cancel out, and I'll multiply by 9 over 5 on the other side. This leaves me with 45 equaling F minus 32. In order to solve for F, I need to add 32 to both sides. And I get that when the Celsius is 25 degrees, the Fahrenheit would be 77. And yes, we did solve for F. Pause your video here and try to solve for F in a literal equation. What did you get F to be? Well, let's walk through the same steps again. We're going to multiply by the reciprocal, which will cancel out 5 over 9. But when we combined, 9 over 5 cannot simplify when we multiply by c, so it's just left as 9 over 5c equals F minus 32. Again, to solve for F like we did it before, we're going to add 32 to both sides, and we get F is equal to 9 over 5c plus 32. Here is one last equation I want us to look at together. When we look at equivalent fractions or equivalent equations, whatever is on the left-hand side must equal the right-hand side. If you can't tell already that this is reducible, another way of solving this would be to do cross multiplication. If I multiply p to 27 and 63 times 3, I end up with 27p equals 3 times 63. When I simplify, I get 27p equals 189. Since 27 is being multiplied to p, I need to do the opposite operation and divide by 27 to both sides. This gives me that p equals 7. To double check this, plug 7 into my denominator and you'll notice that 27 over 63 does reduce to 3 over 7. Follow those same steps over here with our literal equation. S over p equals y over k. If I cross multiply p times y and s times k, I get y times p equals s times k. Please note that if your variables are switched around, it's okay because multiplication is commutative. But now, since we're asked to solve for p, I need to divide by y to both sides, giving me that p equals sk over y. Tomorrow's entrance ticket. Before coming to class, solve the following literal equation on a separate piece of paper. Self-monitor your understanding by placing your work into the got it, kind of got it, or note folders as you walk in. See you tomorrow.